the topic mentions, it's intelligence-based robotics, and I'm an assistant professor at the Department of Aerospace Engineering in Tohoku University in Japan. So the agenda for today's talk will mostly be based on how and why we can use space robots in space, and what are the different conditions in which we can use robots, and how we can make robots more intelligent, as well as the challenges that can be solved if the robots are more intelligent, and some examples of the state of art research that is going on in this field of artificial intelligence in space robotics. So on Earth, we have various applications of robotics, right? In factories, in healthcare, in warehouses, for disaster management and rescue, and even in the entertainment industry, there are so many different applications of robotics on Earth. But what are the applications of robots in space? So these are some of the applications where we can use robots in space, such as deep space exploration. As we know, like the Hayabusa mission, if you know from JAXA, from the Japanese agency, the Hayabusa 1 and 2, they were deep space robotic missions that went to the asteroid Itokawa was for Hayabusa 1, and Ryugu asteroid, which was for Hayabusa 2. So these were like robotic missions that went to these asteroids, collected samples, and brought back to Earth. Similarly, there have been missions to this comet 67P, which was a Rosetta mission, which was also a robotic mission, and the Cassini and Huygens mission to the Saturn's moon. So these were all very robotic spacecrafts that could go to these deep space bodies, celestial bodies, and can collect information, collect sample, and do either like do some experiments on board or bring it back like a sample return mission. So that's deep space exploration. Or we can use robots for survey of planetary surfaces, such as for Moon or Mars, like we have the Curiosity rover, and the most recent, the Perseverance rover, as well as the Ingenuity, which is currently on Mars. So these are all robotic robots which can actually survey the surface, can take pictures, or can collect samples, conduct some experiments, or send data to Earth. Also for assembly and construction, the robotic arms, which are on the International Space Station, those can help in capture of the Dragon capsule, or fixing some parts of the International Space Station. Even maybe you have seen how the solar panels of the International Space Station were actually like assembled using the Canada arm too. So and in future we will have like some construction robots that can help to build habitats on the surface of Moon or Mars. So we can use robots for assembly and construction, and service and maintenance. Like there are some robotic satellites, and like a lot of satellites that are being built, which can help in servicing other satellites. So those can have like robotic arms and tools, and they can help in refueling other satellites, or help in fixing some tools, or if another satellite is not working anymore, it can try fixing try seeing what's wrong. Or for example, if there are telescopes on the orbit, and if there is something wrong with the telescopes, these maintenance robotics or maintenance spacecraft can go and do the servicing. So that's also where we have robotics and autonomy, and also robotic landings. So maybe you have seen the recovery of the boosters of SpaceX um, rocket. So how do they come back exactly on their spot? How do they land back to the spot? So there is some robotics and autonomy and intelligence integrated in that as well. There are cameras, there are sensors that can help in these robotic landings. So uh, in future, when we have spaceports on Mars or Moon, when we have habitats, we can use this intelligence robotics and for coming back to Mars and Moon as well as on Earth. So these are various applications. The most popular applications, of course, there are many other applications of uh, robots in space, but these are the most common and most uh, practical applications that we can have of robots. So basically, the robots are designed according to the environment that they are supposed to operate in. For example, orbital robots, there are two major categories in this field, which is orbital robotics and planetary robotics. So orbital robotics are more that are operating in microgravity, such as the robotic arm for the International Space Station, and as I said, like servicing and maintenance satellites, and also uh, is there a question? Okay, so yeah, basically, we have to design the robots according to the environment that they are supposed to operate in. Like, for example, in the if they are working in the orbit in the microgravity, like for removal of space debris or for maintenance and servicing and refueling of other satellites, then they have to be designed in a specific way and tested in a specific way by creating some microgravity conditions on Earth and then qualifying those robots for space. And planetary robots are more like probes that are used more for the scientific exploration. So these robots go to the surface of the celestial bodies, such as planets or comets or asteroids, moons, and they conduct experiments or collect samples from the surface. And these robots can have different kind of systems, such as they can have wheels, they can have you know tumbling mechanism like jumping if it's on an asteroid, or they can have some limbs walking, or kind of uh, yeah, like limbs, so that it can walk on the surface of the body. So these robots are more like precursors to future human expedition to remote celestial bodies. So these robots can help to understand these celestial bodies, to study, and also to have more better idea of how these celestial bodies can actually support human habitats and humans. So okay, we know that so far we saw how robots can be used in space, but why do we need to use robots? Like, we have astronauts, we have humans. Why do we need to send robots to space? But there are various advantages why we need robots, because we cannot risk sending humans in hostile places like in space, because there are so many different conditions of microgravity and space radiation and extreme temperatures. Also, like the cost of sending humans is very high, and also there's risk of having okay, okay, there's also risk of having the humans in space, because the environment is unknown, and of course if you want to make a safer environment, then you have to spend quite a lot of money. So instead, if you send robots, then it's much more cost effective and less risky. And also there are very difficult tasks that has to be done in space, like for example construction of habitats or on orbit servicing, and sometimes even in invisible locations, like maybe under a cave on moon, or small um, under the rock on Mars. So these are very difficult for humans to do, even on Earth, especially if you are wearing a lot of astronaut suit, and you are like having gloves, thick gloves on your hands. So it's very difficult to do tasks like these. So instead, if you can have robots or robotic arms doing these work, it makes the things easier, right? So these are some various advantages that robots can give in space environment. And following that, the question comes: how can robots do these work? Like how to give them the ability so that they can actually intelligently do these work in the same efficiency as humans. So the answer is basically you make them more human-like, right? You give them a brain and a nervous system so that they can sense, think, and act, so that they can understand the environment, mm, uh, and basically try to uh, grab what's happening around, and have the stimuli control and can communicate within its system as well as with the environment, and then it can act. So typically on the left, you can see like a human system where it has a brain and a nervous system, and the arms, which are the actuators. You can connect them to uh, like your brain gives the signal, and the actuators, which are our limbs, like the arms and the legs, act in a specific manner. And again, there's a feedback control, and then it's a closed loop. Similarly, a robot can be made intelligent by giving it the ability to sense. So if you can give like many different sensors, like camera or audio sensors, or wheel sensors, and haptics or touch sensors. So if you give different types of sensors on the robot so that it can perceive its environment, and then you provide some kind of controller, or a micro processor, so that it can think uh, what it has to do based on what it senses, and then it can act, which is through actuators. um, like it can move forward or move back, or uh, you know it can control its motors, basically the different actions that it should undertake. So that's how you can make it more intelligent. It's the most simple way to say how a robotic system can be intelligent. And thanks to our recent advances in the semiconductor and electronics and MEMS sector, we have many sensors which are like miniaturized sensors, and we can actually equip our robots with different kind of sensors and also processors so that they can actually have these qualities. Okay. So basically, after you give these properties, or after you give these hardware, then comes the software, which actually helps in making the robots more intelligent. So maybe you have heard a lot about Internet of Things, big data, machine learning, cloud computing, neural networks, convoluted neural networks, and all these things. So what are these? These are basically more advanced form of computing in recent times, which actually help the robots uh, under, to learn from its environment. So you give the sensors, and then you make the robot learn from what it's experiencing. Just like you can think of a newborn human, as the human grows, it experiences many things, and it learns and it stores in its brain, like it stores the experiences, it stores the memory. And just like that, robots are coded in a way that they actually store this data, what it's experiencing, and then it learns through machine learning or deep learning, yeah, or reinforcement learning. So these are what makes a robot intelligent. So you can just think of how humans become intelligent from their experiences, from our from what we see and what we think and how we remember. That's how robots can also be made intelligent. And currently, there's a lot of research going on in this sector of like to improve the storage and the sensing and the perception uh, capabilities of robots for to become more intelligent. So there are various challenges in the space robotics sector that can be solved by making robots more intelligent. Like we have, as I mentioned earlier, that the space environment is very hostile. So if we have uh, intelligent, materials by which these robots can be made, we can have these materials in a way that they can change according to how the environment is. So, if it's too hot, if the temperature is too hot, then the material can cool down itself. And also, if there's too much radiation, it can try, um, having more protection, or increasing the number of layers or growing number of layers. So there can be like artificially intelligent materials, also mobility in different terrains. This is one of the researches that are very popular, uh, also in Japan and Germany, and my lab is also working in this. So how a robot can, or a rover, um, not just rover, also like walking robots and wheeled robots, how they can move in different terrains, and if there are like cliffs, or if there are rocks or hills, how can the robot learn uh, and understand the environment and move and try to avoid obstacles and collisions. So if the robot is given this autonomy and given this uh, intelligence, it can really move in a much better way than actually being controlled by humans. Mass and power limitations can also be solved by
So,
artificial intelligence. So if we have like yeah, if we have AI powered robots, it can try to adjust its power requirements according to the situation. So there are already many systems on Earth uh, which are implemented with this. So on space also this can be implemented. Control and interfaces, navigation and path planning, of course, these can also be solved using machine learning and deep learning, because we can have like image segmentation, or how the robot sees, and how the robot the cameras can be equipped with enough artificial intelligence and processing so that it can navigate in a much safer way. Also, autonomous capabilities and remote operations like teleoperations can be reduced if the robot is more autonomous. And uh, also testing and qualification. So, uh, as you know, like before we send robots to space, we need to have properly tested and qualified so that it can be launched. So, but this testing and qualification is very expensive, and not everyone can actually do it other than the big space agencies. So, if we have an AI model that can help in a software that can help in just testing the robot model, that can actually reduce our expenses and help us to qualify much faster and in a much cost effective way. So these are some challenges that exist, and AI can really help in solving these issues. So, as I said, we come to the some state of the art research that's going on in artificial intelligence, and I'll list two of my favorites. There are others as well, but yeah, we don't have a lot of time, so I'll go ahead with two topics, which are swarm intelligence. So, swarm is basically a group of homogeneous or heterogeneous robots, which can communicate with each other and can form a network, as well as like they can they can learn from the environment as well as from each other, because they are always communicating. You can think of a swarm as a quasi organism, like a swarm of bees or or a group of ants. So they are always sharing information, and they can adapt to the changes by following some specific behaviors. And this is called hive learning. So the entire swarm learns how the environment is by just like sharing the information. And this greatly optimizes the exploration strategies, because it helps to understand, to map the environment in a much better way, and also to it can become much faster. So swarms have not been implemented on in space yet, but they are used in factories. You might have seen swarm of drones that many different companies have launched. So these are basically technology demonstrations of how swarms can work together, and they are actually like pretty intelligent. You might have seen some videos of swarm of drones working together. And how do they become intelligent? It's because they each of them have their own sensors on board, and they also share the data. So they are very adaptable and robust, and they can be scaled. So you can have 10 robots, you can have 20 robots, 100,000 robots, depending on how what kind of exploration that you want to do. So that's one topic that's really getting very popular, and it was also my PhD topic, where I worked on path planning for swarm robotics based on the communication network that they form, and uh, as they like share the information, how they share the information and they continue to cover the lunar surface, and as well as they do a very efficient path planning, which reduces the time that they have to that reduces the time that they need to cover a specific area. So this is definitely something that you can look into if you're interested. And the next one that I want to talk about is the human robot interaction. So, this is another very interesting topic for artificial intelligence in robotics, because, as I said, we want to make robots intelligent, but the end goal is that we can have robots and humans working together, right? Humans and robots have to be like colleagues. And for that, we have to give the robots enough understanding, enough intelligence, so that it can have a very friendly interaction between the astronauts and between the it can have a very friendly interaction with the astronauts. So yeah, it should be able to like express, it should be able to understand, and also show some emotions, so that just like another astronaut would do. So that's one topic for where artificial intelligence really comes into application, and where you can actually teach the robot from its experiences, and uh, you know apply deep learning and reinforcement learning, and give it the capability to understand the biophysical logical signals, so that it becomes more social and more friendly to astronauts. And here you can see like two pictures. On the top is actually a robot called Simon, CIMON. It was developed by the German Aerospace Center, and it's on board the International Space Station, and it is an assistant robot for the astronauts. It can fly around, it can um, understand the environment of uh, in which the astronauts are working, and it can uh, you can think of it just like your mobile phone, which can be assistant. You might have Siri or Alexa or the Google voice. So you give some instructions to the assistant, and the assistant does the work. So it's very similar to that, and it also uh, responds in specific ways in which it can perceive the astronauts and the environment. So that's one robot. Similarly, there is INT Ball by the Japanese Aerospace Center, uh, which is also on board the International Space Station, and it also takes like pictures. It helps the astronauts in conducting scientific researches, and give even like the astronauts can play with these robots. Uh, can you please mute microphone, everyone? So yeah, that's how this assistant helps. And on the below picture is you can see an astronaut with Robonaut 2, which is actually developed by NASA. And this uh, robot has dexterous capabilities as in it uses its hands for different type of tasks, like opening some tools, or helping in construction, and even just like we use our hands for different work. So this robot is actually developed to help the astronauts in different work of fixing things on the International Space Station. And this robot can also understand what are the tasks that need to be done, and how it can help the astronaut by, maybe you can see like there are some sensors on its hand. So it has some haptic sensors. So if uh, it touches some um, other objects, it feels just like astronauts feel. So these are some points, some topics where artificial intelligence are heavily uh, being researched on, and there's a lot other topics. Of course, I'll just show you. These are some upcoming space robotics missions where also artificial intelligence is being implemented. So the direct asteroid redirect, double asteroid redirect mission DART, which is like it will go to asteroid and it will try to redirect it towards Earth. So that also has some artificial intelligence so that it can actually maneuver the asteroid in a specific way. Also, the MMX, which is the Martian Moon's exploration mission, which will be exploring the two Martian moons, the Deimos and Phobos. And it will also be uh, collecting some uh, samples, and it will also land a rover on Phobos, which has artificial intelligence and machine learning capabilities to move on the surface of the Martian moon. Similarly, there's another mission which is coming up, the Dragonfly mission for Titan, the moon for Saturn. So Titan has a very dense atmosphere, and therefore Dragonfly is a flying robot, and it will be exploring the environment, the atmosphere of Titan, and try to adjust its flying speed, and its where it should go down or where it should go up, and trying to analyze the density of the atmosphere at different points, and just like an intelligent drone would do. And also the ExoMars mission, which is supposed to be launched later this year. It has quite a lot of artificial intelligence and laboratory on board. So it will be digging the Martian surface up to 2 meters deep, and it will be collecting samples and conducting experiments on board. So you can think of just like a chemist or a physicist on board the spacecraft. So it has quite a lot of intelligence on board, and also the cameras, the eyes, or there are sensors on the wheel to understand the terrain and things like that. So these are some of the things that I can share for how artificial intelligence is being used in space. And I think that's it from me. And thank you very much for your time. Uh, if you have any questions, please go ahead. I'll be happy to answer your questions. And yeah, if you want to connect with me, you can scan the QR codes and check my work.
Everyone, finally we drive to the final sections of the today's workshop. So if there are any questions, you can ask Rhea because I think the topic today is very amazing. You know, like we're going to explore, we're going to make the amazing thing by AI and many things like robot to explore outside rather than the world. Yeah. Okay. If some
Yeah,
of you
sure.
have any questions, like you can type in the chat box or just unmute yourself to ask.
If you have any questions regarding to general robotics as well, I'll be happy to answer. If you didn't understand something.
While waiting for like some questions, so I also have questions too.
Yeah,
So as
sure.
you might know, like some of robot, if we think about the movement of the robot, if we send the robot outside the earth, we have to like think about many factors. So my question is, what factor and what parameter that we have to decide the robot? Because like if we go outside the Earth, there are ledges. I mean, like the gravities and also pressure, and also the
Hmm.
density of the air too. Yeah. So
Yeah.
yeah, what is the factor and parameter that we're going to think before we're going to create that robot?
Yeah, so it depends on what your mission is, the mission objective. If you are going to a low gravity mission or a low gravity body, or if you are going to body where the rover or the robot moving around on the surface. So you can like uh, as you start with the mission objectives, and then you start designing the robot based on the factors of its operational environment, like as you said, gravity, the temperature, the pressure, also the if it's a planetary uh, robot, then how is the surface, the terrain, the is it very rocky or is it smooth? You can have these information from the satellite data, right? So, but sometimes you cannot really predict if it's right. For example, the Rosetta mission, the Philae robot, which landed on the comet, right? It was not known where it will land. And so it landed under a rock where there is no sunlight. And so there is no power that the robot is not able to get the power. So you have to think about those kind of risks as well. So if there is no sunlight, how will the solar panels be powered? So maybe you should have some, RTGs or nuclear powered uh, modules, or you can have some batteries to help it to be powered for some time. So these are some factors. Also, the mass depends on how you are going to launch it, because on Earth there are limitations for the launch. If it's very uh, heavy, then you will have to pay quite a lot. So the mass, if you want to make it smaller and still have all the capabilities, so that's one factor you have to take into account. And that's where the swarm robotics can come into application, or modular robotics, where you can have small parts of many different robots, and then these robots are not so heavy, and they can be launched one at a time. And then in space, they can come together as a system, and then it can work, and the objective can be fulfilled. So these are like different kind of objective, like factors that you need to take into account.
Thank you, Shreya. That's very useful. Oh yeah, and there are some questions from Hidaya hi Sam, if I pronounce correctly. So he just wanna ask if it's possible to get the slide from today's presentation.
Right? Yes, I can send this.
Yeah, so did you hear me?
Sorry?
Hello? Do you hear me?
Yes, for you.
Yeah, so he asked if it's possible to get the slide for today's presentation.
Yes, I will send the slides for the presentation.
Yeah, so where will you send the slide?
I will send it to Pirarus.
Oh, okay, that's fine. Thank you. And also there is a question from Shanghai Tan. Uh, he said like AI for space application need to be trained and evaluated before deployment. What are the considerations to acquire training data set and to ensure evaluation is sufficient to qualify for deployment?
Yeah, that's a very good question. So the thing is, unless you send the robot to space, you don't actually have the data. The so you have to rely on uh, data, data like from the satellites, from the past missions. So can you hear me properly?
Yeah. We can hear you.
So you have to rely on data from the past missions, such as if you know the Martian missions, you can. That's a very good example. So it started from Pathfinder, then Sojourner, then there was Opportunity, and also the other of course, the curiosity and now perseverance. So you have quite a lot of data from the past missions, and from these missions, the future robots are trained based on the that data. Other than that, of course, you give this capability to the robot to learn from its environment, and for that you have to test the robot before you launch. So you test the robot on Earth, you take it to analog sites, like for example, NASA tests its robot in the Mojave Desert, uh, where there are like rocks and craters and cliffs, just like it would be on Mars. So you can train the robot to understand that environment and learn from that environment. For icy moon robots, they take the robots to Antarctica or to the North Poles or South Pole, and they test the robots. If you see some NASA videos, they have really cool videos of how they are training the robots in Antarctica. So these are some some ways where you can test and train the robots, and uh, like there are different um, levels how you can evaluate um, testing and the training phases, just like you have the uh, technology readiness level. So you keep testing and training the software and the hardware unless you have a high level of 7 or 8, and that's when you can launch. So it takes many years to actually come to that point, and that's why like space missions can take so long. It takes 10 years to just develop. So and then you can behind it to learn more. Answers the question.
So, so there was a questions again for Miss Cheng Hai Tan. So, if there are lack of past that data for training, like for a totally new mission, what method can be used for a non-supervised training?
Yeah, by training. Uh, as of now, I know perseverance is quite a lot of non-supervised training. Uh, mass with RCNN and sensors have board. Audio is not clear.
Excuse me, Miss Pin Tang, so can you mute yourself because I think like the sound is not
Sorry,
really clear.
did everyone please mute?
Okay, so I think that's good.
Yeah.
You can continue. Yeah.
Uh, you can use non-supervised training, such as RCNN and yeah, deep learning methods, reinforcement learning methods by which it can actually understand and the environment at every step. So it takes a step and it decides, okay, this is not how it should be, and it should be the other way, and then it tries on its own. And this actually, non-supervised training can also help in reducing a lot of human errors as well, because there might be some issues with teleoperations or remote operations or scheduling, manual scheduling. So non-supervised training can help in that as well.
Yeah. So thank you for your answer and every questions that asked. So okay, finally we just end the lectures. Thank you again to Shreya to give us a great inspirational lectures and for us to have the idea to make the proposal for the AI Space Challenge. And also again, thanks to the Ice Cube, Inif, Frantism, and Space Up to create this good event. And also thank you our sponsor, Digital Insight, for being very supportive. So yeah, and again, you can keep follow the next workshop via the website. And also the slide of the presentation will be posted on the website too. And the proposal of the AI spatial lane is also available to send until the 15th of February. Yeah, and thank you again everyone for joining this lecture. Hope everyone have a wonderful time for the rest of your day. And see you again at the next workshop. Bye.